This
Fitzer.
conference will now be recorded.
I'll start again. Just a quick introduction. My name's Fitzer. I work for WSP as a permanent way engineer. I've been working in the rail industry for approximately 5.5 years now, and I'm currently acting as the alignment lead for Stage 2B on Etihad Rail. So I've also had previous contracts on the job working as the track work engineer and interface manager for Section 2C. And last year I spent some time in both Abu Dhabi and Dubai working in the client's office. So I've been really in the thick of the project on what we're going to be presenting today.
So my name's Kevin Mann. I joined the WSP track team a little over a year ago now. And this project is actually my first project from joining the railway industry. So
yeah, I'm Alex Torevell, and I've been working for WSP as an apprentice engineer for the past around 18 months. And the Etihad project was my first major project, and I've been working mainly on the production of drawings and CAD related work on the project. So to start the presentation, since the end of 2019, WSP have been working as one of the main design consultants on this project, which is based in UAE. And this presentation is going to give a brief oversight of what our role entails and some of the unique challenges we have faced due to it being an international project. So the Etihad Rail project is for the design and construction of the first major heavy haul railway through the United Arab Emirates, stretching from the border with Saudi all the way to the coast. The overall project is made up of 3 main stages and split into 2 further substages and sections. At first, the network will predominantly be used as a commercial freight route with plans for passenger capabilities in the future. Stage 1 has already been constructed and is under operation, and Stage 2 is currently undergoing design and construction. WSP are contracted to do the railway and civils design through 2B and 2C, which stretch from Tariff Junction to the connection with Stage 1 to Sharjah to connect with 2D, which is being designed by others, and are contracted from preliminary design all the way to ASC. The Manchester team are working mainly on 2B, whereas the Birmingham team focused on 2C. And that the 2B will form the base of this presentation. 2B is split into 8 sub-packages, 6 main line and 2 freight branch lines that run to freight facilities. The majority of the alignment is twin track, although there are areas of single tracking. There is also branch line connections that run parallel to the main line and set off tracks that are designed for stabling maintenance vehicles and road rail vehicles.
So the project client is Etihad Rail, and Stage 2B was awarded to a joint venture between China Rail Construction Engineering Corporation and Gantu Transport and General Contracting Company, so that's CRCC GTGC, and we refer to them as the JV. The JV control the construction, procurement and approval of a design. So we are one of the JV subcontractors and are contracted to undertake the design of the railway and civil works, including a highway and utility redesign along the railway corridor. So some of our typical disciplines that are involved are alignment, track work, earthworks, geotech, environmental acoustics, drainage, highways, structures, utilities and line side. Jacobs are appointed as the client's engineer and are responsible for approving the designs that we pass through to them via the JV. So they provide us with our DRN comments upon reviewing our packages. So the UAE don't actually have their own railway standards, so a project-specific standard was actually created. It was formed from a combination of UK, North American, European and Australian standards, and include some of them which are shown on screen. We found that there could be conflicting information within the actual project-specific standard that was created, or extracts taken out of standards with little context or missing information. So this really prompted us to work very closely with the client engineer to find suitable solutions and compromises. So it's important to mention some of the design criteria and limitations which really affected the way in which we designed. So on screen are some of the main parameters that really affected the designs, both horizontally and vertically. So an example of this being the maximum train consist and how it affected the number of grades within the proximity of the vertical alignment. It was particularly challenging through some of the suburban areas where we had a lot of assets controlled by other disciplines, which we had to try and navigate.
Oh, was it muted?
Yeah, sorry, go on.
So we produced drawings that included interdisciplinary inputs to facilitate the communication of our design to the client. Now, due to the size of the overall alignment, scales of our plan and profile drawings were set at 1 in 5,000, showing up to 3 kilometers of track in each drawing. These drawings showed our alignment incorporated with structures such as overbridges, underpasses, culverts, bridge crossings, and due to the graphical occasion, we also include structures like reptile crossings. We also produce more detailed drawings that are at a scale of 1 in 500, displaying up to 300 meters of track to show the S&C units in great detail. That being said, the majority of the S&C on this project is quite simple, only due to the fact that it was built brand new. So there were no existing faults that need to be adjusted. And despite using a large scale, there was still a considerable number of drawings that needed to be produced to cover the alignment, ranging between 25 to 35 drawings per ELR submission. This became particularly challenging when our project became fast-tracked, resulting in us having to produce 1 ELR submission a week. That's 25 to 35 drawings in a week.
So we are based in Manchester as the alignment designers. The client, the engineer, the JV are all based in the Middle East. We've got teams from various design disciplines all around the world, such as the line side designers in South Africa. We've got sand mitigation experts in North America, and we've also got a lot of CAD resource in India. So effective communication is something that we really had to work on. We've often had to be flexible with our working hours in order to attend interface meetings and to deliver packages to the program effectively. So the Middle East standard working week is a Sunday to Thursday, which obviously differs from the UK Monday to Friday. There's also a cultural difference in regards to the delivery of the project, and in particular, the design and interface meetings. We've had to have an appreciation for language barriers and how we put across our points of view during discussions. So as with all projects, we've had to find a way to balance our scope triangle to satisfy the time, cost and quality for what we're expected to deliver. So we deliver to various clients, which include the JV and Etihad Rail. Their main concerns or focus can vary slightly. So the JV are the construction consultant, and with their procurement and construction program, their primary drivers are often time and money. Etihad Rail will put a lot more emphasis on quality. So we need to be able to find a balance for the various client expectations. So we have various interfaces along the railway corridor that we had to coordinate with. Some of these were being developed by other subcontractors or consultants. For instance, the systems contractor or the depot facility designers were external contracts that we had to work with. So inputs were recorded and controlled in interface control documents, which drive a lot of the interface meetings. So for internal coordination, the 2B design interfacing was driven predominantly by the alignment team, with our design models being distributed to other disciplines first. This was one of our major roles on the project, and as a result, we created tools that allow us to have coordination and consistency between all disciplines. It was critical that we had control for single sources of truth due to the scale of the project and the ever-changing program dates, which varied discipline to discipline. There have been several instances of the program being accelerated by the client, which leaves quite a short amount of time for actual interfacing. So on the screen is an example of a structure schedule which we created so that various disciplines such as alignment, highway structures, hydrology could all input into for interfacing which could then be done in tandem with the individual design development rather than relying solely on IDCs at the end of design stages. So the schedules eventually evolved to assist with the procurement teams as well, with track work quantifying for elements such as ballast mats and guardrails.
Kevin, are you presenting?
Hello.
Yeah, go on.
Sorry, I was having some technical difficulties. Can you hear me?
Yeah, that's a lot clearer now. Thank you.
Yep. Okay. So one of the more unique design aspects of the job is working with the sand mitigation experts for stopping the sand from contaminating the track form. And a lot of design for the mainland is through rural areas, so there's no actual protection from the wind, and there's a lot of sand. Now, what sand contamination does to the ballast is increase the track stiffness and damping, which can lead to wear and degradation of the sleepers and track bed at an accelerated rate. It also allows the track formation to maintain a high moisture level and degrade quicker. We can see here the two main mitigation options that we adopted into our project when we deemed to be running the railway through an area of high wind and sand exposure. We have a ditch and berm and a ditch and fence. Fence is used to replace the berm when there are space constraints within the right of way. The berm is typically made up of a sand gravel fill, and ditch is made from a cutting to the natural subterranean material. The ditch and berm work together to trap the wind-blown sand using convection current, forcing the sand to fall back into the ditch and away from the track farm. It is required to carry out maintenance to remove any sand buildup within the ditch, as lack of poor maintenance, lack of mitigation, and improper installation can lead to sand contamination and potentially result in track form failure, as shown in the picture. Now, this is an image from stage 1 of the project, where the sand mitigation had unfortunately failed.
Throughout the project, we have touched the right of way several times, and it's important to note how this influences our design. The right of way is the space provided for the rail corridor and is typically determined by land acquisition and stakeholder agreement on the project. Through some of the more rural areas, the military owns facilities and are considered one of the main stakeholders on the project, so it is important to avoid their land. ADNOC, the Abu Dhabi National Oil Company, the state-owned oil company in the UAE, also has a lot of assets situated in the land around Abu Dhabi, which contributes to the country's economy, so are again another major stakeholder. It is within Etihad Rail's best interest to avoid any stakeholder assets, including access to land. The right-of-way has been shifted in several areas at various design stages where there is a conflict of interest between stakeholders. Even coming to the end of detailed design, there's still some shareholder conflict to be resolved. One of the ADNOC requirements is to provide ridge crossings along the alignment for the oil rigs. The rigs that operate in the area are some of the heaviest vehicles in the world, and the bespoke crossings have been designed in Australia to withstand the axle loads from these vehicles and provide safe passage. A standard rail crossing will have fixed embedded track form. However, the imposed issues with potential sound build-up in the flange. The proposed crossing comprises of a concrete approach slab with removable panels on top of ballasted track. Anticipated rig dimensions are 17 metres height, 60 metres length and 22 metres wide, and rig crossings are designed to be 30 metres wide. Combined weight of ridge substructure with dollies is approximately 620 tonnes. Our role as the design team has had us working closely with the manufacturers to ensure that any design limitations to the railway are considered in both our design and ridge crossing design. Considerations such as sand mitigation, access ramps, which is affected by the embankment height, vertical geometry, and assets in the surrounding area has to be taken in when designing.
So just to finish off, that just gives a brief oversight of some of the main constraints and some of the main points of interest on the project. We're currently working to finalise our last few detailed design packages, although there are still some areas that could potentially change due to stakeholder conflicts. We've also started to prepare models and drawings for AFC delivery. So we should be finishing up the project in the next few months, and even though it's been tough, there have been plenty of lessons learned on the project. So feel free to ask any questions and we'll do our best to answer. Thank you.
Okay, is there any I've got a question from Saki. He says, what happens in the case of a sandstorm?
So in terms of the actual alignment, if I go back to probably this slide here, the actual alignment corridor is relatively coastal, as opposed to being in the thick of the desert where you have your big sand dunes. So typically the actual sand mitigation which runs alongside the alignment through the corridor is normally sufficient to actually stop that. And obviously the sand mitigation, it's really important that it's maintained correctly. From the image that we showed of stage 1, where the sand actually contaminated the track form. So really it's down to a maintenance requirement. But the actual sandstorms, I don't think there's ever really any instance where that's really going to affect the rail corridor as such, or as I believe from talking with the sand mitigation experts.
Okay, any more questions? Just what I mean, I'll probably put some hauling questions in. So, I mean, what is the kind of length of the freight vehicles going over this section? Is it predominantly oil, or is there other freight being taken across these sections?
I couldn't tell you the exact freight that's going across. We do have some slides on here. I mean, mainly the freight facilities are at the end of 2 of our branch lines. Get the schematic up. So the end of the branch lines, the ICD and the KPZ, are 2 of the freight facilities which are being designed by others, and they are typically offshore facilities. So it'll be cargo coming in from ship, which will be put onto the freight trains and driven around. Not sure exactly what the actual cargo is as such, but we designed to have twin stack freight containers along the route. The actual length of the trains for the freight trains is typically 2 kilometers as well.
Okay, thank you. Andrew Hurst has got surprised to see no OLE as part of the design. What was the thinking?
Yeah, to begin with, the majority of the network is going to be used predominantly for freight, with the idea of passenger is going to be introduced in the future. So there is actually future provision for OLE that we have to consider. So no OLE is directly designed at this stage. However, we've had to take into consideration future OLE, so space provision for it. So obviously I've not really put that many technical drawings into the slideshow. But on a lot of our cross sections, we do actually show OLE masts, or typical OLE masts, for future provision.
Okay, thank you. There's a question here about how is continuously welded rail managed? What's the maximum temperature range allowed? I imagine it's welded rail, is that correct?
Yeah, so it's CWR all the way through. I think on 2B, yeah. To be honest, the actual temperature range isn't actually as extreme as we might think. My first initial thoughts were, I know when you go into like the middle of a desert, you can get extreme temperatures, whether it's not just heat, but then it's coldness as well at night. And I know in Saudi, they have issues, especially going through mountain areas where, as well as the rails getting really hot, they can actually ice over at night. But the recorded temperature ranges along the actual railway corridor that is being proposed is actually not too dissimilar to the temperature the difference in temperature that we sort of experienced in the UK, which actually surprised me at first as well when I first came across that.
Yeah, absolutely. Yeah. So another one from Andrew Hurst. What implications are there with CWR and extreme temperatures, hot in the day and cold at night? So, I mean, is there a wide range there, or not? Are you saying that's kind of not as wide as we would expect?
It's not as wide the range as what we'd expect. I think it ranges off the top of my head about 40 degrees. Which, to be honest, I think it gets a lot worse in other parts of the world, in North America or places like Australia, Saudi, for instance.
Okay.
Yes.
Thank you. Phil Singleton said, when reviewing the standards worldwide to create the project standard specification, did you pick up any best practice that the UK could adopt?
So we didn't actually create the project's specific standard. It was a standard document that we inherited when we joined the project. So we picked up the project at the preliminary design stage and took it all the way, and are taking it all the way through to AFC. So to be honest, we've had quite a bit of issue with the actual document which was pulled together. I mean, a lot of the time it's to do with either conflicting information or there being a lack of information, especially being a UK design team. We are very much used to using Network Rail standards for designing railways. So when something varies slightly or something's missing, we look towards the Network Rail standards. For instance, an example might be there's missing information to do with cant gradients in the project-specific standard, which we had difficulties with. So we adopted Network Rail standards, but I think it caused a bit of confusion with the client's engineer. So I mean, if there's anything we could adopt, I'm not too sure, to be honest. A lesson learned really from looking at the difference in standards. Maybe just read up on standards and know different standards.
Okay, next one was Keith Griffiths. Is there much increased rail wear? Is a wheel flange lubrication? Is wheel flange lubrication used at all?
So I won't say there's any real increased rail wear as to what standard. See the grade of steel that's been specified for the actual rails themselves has been calculated by the manufacturer based on the typical axle loads and the tonnage on the network. In terms of side wear, I mean it's not really too bad when you're designing a brand new railway. We typically keep the geometry lengths and like your size of radii as large as possible, just to make it more streamlined and easier. So we never have any instances where we have to adopt like gauge widening, for instance, or anything as such. So I wouldn't say the rail wear is anything too abnormal.
Okay, Andrew, what have you done for cable routes and protection from sand ingress?
So yeah, we've designed the line side in terms of the cable routing. And we're working with another design contractor who are doing the systems integration. So they deal with the subsystems along the route and then all the cabling for the signalling. In terms of the actual cable troughing, though, and the cable protection, it's typically by the toe of the ballast. So it's within inside the actual railway after the sand mitigation. So we typically don't expect to have a massive buildup of sand over the actual manholes or cable troughing.
Okay. No other questions? Oh, there's a couple coming through. I'll just squeeze one in from myself. Have you had any key kind of ground conditions that you've had to deal with? from a formation perspective throughout the route? What's been your standard kind of formation treatment, if you like?
Yeah, so we typically just have subgrade going straight into sub-ballast and then ballasted. There are areas, especially when we get close with structures, where we reduce the amount of sub-ballast and use ballast mats instead. There's a few instances, because we are quite close to the coast, there's areas of Sabka, which is almost like a wetland within desert. So we do actually get quite a lot of standing water in some areas. But our hydrology team typically obviously deal with that. Our embankments are high enough as well, where we can have a decent drainage run to deal with any water. So we've sort of designed that out in terms of our actual alignment level, our vertical level. Similarly, when we get down close to the coastline for the freight facilities, we do actually have areas where you get quite a bit of standing water, and it's the same instance. And surprisingly enough as well, actually, you do get quite a bit of water build up around some of the more suburban areas. So in the UAE, along any of the major highways, they like to try and plant as many like trees and bushes actually along the highways, as much greenery as they can, and they use like recycled water and sprinkler systems to sort of irrigate and to keep everything green, but it has actually caused us some issues. There are some instances where we were looking at using slab track to just reduce our formation depth overall, to assist. Used French drains, perforated pipes to take away any buildup of groundwater as well. But we managed to design all that out. So we just have a standard track form for more or less the entire route.
Okay, thank you. Maureen Sackland has put a question in. What are the track quality handback requirements? How do they measure track quality in the UAE? Do they have a version of the NMT, kind of new measurement train, or is this done manually over set intervals?
To be honest, I'm not 100% sure what they're planning on using in the UAE. I could go away and find out and get back to you on that one.
Okay, yeah, it was just, I think the main question there is around track maintenance, that's kind of assessed going forward. That would be useful to know. Andrew Hurst again, I think our top questioner today. Is the railway fenced? Is there any animal intrusion risk?
Yeah, so along the right of way, we typically have fencing that goes all the way along and meets up with any structures as well. We do actually have, it's one of our environmental requirements is to provide crossings for various animals. So there's certain crossings that we have on the project which are reptile crossings. We also have camel underpasses as well, quite close to some of the camel race courses, which are near Abu Dhabi.
Wow.
So yeah, it's part of the environmental consideration, and we keep everything fenced.
Okay, is Carl Phillips has put a question, is the railway all built to the same route availability, i.e. RA10? I guess it's assuming freight's only freight's only at present, so it's kind of, is it all assessed or designed to be built on that same kind of high spec, I guess?
Yeah, so we typically take, when we've been doing the design, we take both the freight and passenger parameters into consideration when designing. So for instance, the tonnage, the weight, the quality of the sleepers and the rail that's being specified, designed to withstand the loading from your heavy haul freight, but then also the actual track geometry is designed to satisfy passenger requirements as well as freight requirements. So it's all taken into consideration.
Okay, I've got a couple of questions from Gianfranco. So do you have a tunnel? If yes, what is the maximum length? And then he's also talked about Camel Crossing. Have you guaranteed the environmental continuity? So I think you were just talking about that. But there's a couple there about tunnels and any comments on that?
So we don't actually have any tunnels on section 2B of the project. There's areas where we've got MSE wall that we've designed on top of, but no tunnels as such. We try to keep structures, especially over bridges, as short as possible. And then we, especially through the over bridges, we try to keep the geometry as straightforward and simple as possible, and try to make sure that we negate putting any S&C close by.
Okay, Mark Sakis, but the ground conditions between the UK and UAE are very different, soil versus sand. What was done to ensure the sand could be strong enough to hold the track structure? I think it's probably what you're talking about with the formation.
Yeah, typically. So it's just within the formation depths, which are sort of standard and they're built up from our geotechnical experts. I probably couldn't go into too much detail about that. I'm not all that familiar with what the geotech team have actually done in terms of ensuring that, but we've been told that that's what we can do.
Okay, yeah, I think that definitely would be an interesting aspect of this dealing on in this kind of environment. I don't know if you yourself or could come back via Dave Parry to inform us on that. Just maybe a last question then, or probably from Andrew Hurst again. Have you all enjoyed the challenge the project has provided?
Yeah, it has been an interesting project. It's been good doing the design because there's a lot of considerations that we have to think about, which we normally wouldn't with a UK Network Rail project or just a UK project in general. I think one of the biggest difficulties has definitely been the communication and cultural aspect, which is why we decided to touch on that in the slides. Trying to understand the differences of cultures and how that feeds in, and the program it's been quite merciless at times in terms of the way it's been accelerated. So yeah, it's definitely been a very big learning curve. I think it's one which has probably allowed all the team working on it to probably take in to consideration some really good aspects for future projects that they can bring back into UK work.
Okay. Any from probably Kevin, Alex, any highlights for yourselves?
Yeah, I thought it's been a good project, and it was my first major project after joining WSP, and it definitely had a lot more responsibility on it to do with because of the producing of the drawings and everything, and the time frames in which you had to do that, and a lot of checking as you went through, sort of making sure you had to be very I can't think of the word, but you had to make sure you were looking at all the aspects of the drawings, and you were communicating with people in different countries, different time zones, and it was definitely a learning curve, but I very much enjoyed the challenge, really.
Kevin, yourself?
Yeah, like Simon and Alex said, it's a learning curve. I mentioned it was my very first project working in the rail industry, so it just allowed me to get used to the process of how track design operates. But yeah, it was a very good project to get started on, and it helped transition on to further rail projects for me. So
great. I have got one last question in there. So Moim Sakwin has put in, where are the track components procured from?
All over the place, quite frankly.
Okay.
I mean, we deal with Voslo for quite a bit of the componentry, but then some stuff like the rig crossings, for instance, because of the sort of tonnage that they have to deal with, it's very unique. I think they are the heaviest rig crossings, or the highest loaded level crossings in the world, which are going to be put onto this project. So we've actually looking at different suppliers from all over the world, and I think the procurement team have settled on a supplier from Australia, but we do typically deal with procurement from globally all over the world.
Okay, thank you. Okay, so before I just go into the vote of thanks, I'll probably just remind you that there is a Young Achievers Award that we're running on this section. So not just for yourselves, potentially you could meet the criteria, but others on the call, I think the deadline is the 31st of July, 2,000 word, 2,500 word document just to present on a railway project. This feels like an ideal one to submit, but just trying to make sure we get some applications. There we are. So on that note, if I could ask Dave Parry for the vote of thanks. Thank you.
Yeah, many thanks to Simon, Kevin, and Alex for your very detailed presentation on the Etihad rail, and particularly the features of that railway, particularly the 2 kilometre freight train and all the peculiarities of trying to fit that in. And you did mention about all the interfaces that you have to deal with, and I'd probably just elaborate on that a lot of the other disciplines, it was their first rail project, so Simon and the team really had to do a lot of educating the other disciplines on how all their features would affect the railway, and just principally how the railway works in terms of, you know, impacts on one area affects the other, and right through to understanding the complexities of the design process of building a railway, and how you need to fix one component before another, and they managed that really well. And as Simon said, it's the difficulties of working with different cultures. You know, quite often there'd be phone calls timed with people in 3 different continents, not even just time zones, so some would be right late in the evening, while for the UK it was really early in the morning, and just the challenges of trying to deliver week in, week out. So they did a really good job, and yeah, many thanks for your presentation, and also the other details relating to things like the sand mitigation, trying to keep the sand out of the track, the peculiarities of the rig crossings, trying to satisfy the stakeholders that really have a lot of power in the Middle East, that you have to keep happy, and yeah, and very well done all round. Yeah, so if we can thank them in the usual way, that'd be good.
So, yeah, if you could unmute yourself and we'll give them a round of applause, that'd be great. Yeah. Thank you very much. The next section meeting is on the 15th of April, and we're talking about the West Coast Main Line line speed profile there. Thanks again, guys, for presenting today. Much appreciated. Okay.